Okay, we're on part 1b. And this is the integral that I'm interested in, and it is an example of what we're learning today. Up to now, all the integrals you basically could have gotten from old material and from your memory. So this is new material. The integral of sine cubed x cosine to the fourth x dx. The strategy, I'm actually going to write the words out. The strategy for these kind, when you have this, especially this degree 3 or even other odd numbers, works well with this strategy. I want you to save, and I'll describe better what the word save means. Save one sign and change the rest. And why are we saving the one sign? That's going to be for our du, and change the rest change the remaining to cosine. So let me zoom out a little, see if I can get that statement in. The strategy is to save one sign for our du and change the remaining to cosine. All right, so that's not going to mean a whole lot until we actually do one. So we're going to do this one. All right, when I rewrite this integral, I'm going to save one sign. So I'll put it down here, sine x. Now I can't just change the problem because we started with sine cubed. So I'm going to put back my sine now squared. So I have the equivalent of sine cubed, but I've saved one out. Then what's left in here is cosine to the fourth x and good old dx. All right. The reason I split this up and saved this one sign is I'm going to establish an expression in cosine, which will be my u, and this will serve as my du. Let me show you. So sine squared, going back to the key was sine squared x plus cosine squared x equals 1 from our trig ID phase. We know that we can substitute sine in terms of cosine by rearranging this. So rearranging this, I get sine squared x equals 1 minus cosine squared x. So everywhere there's a sine squared x, I can replace it with a 1 minus cosine squared x. And then I have followed my strategy to change everything to cosine except that one sine. So my sine squared has become 1 minus cosine squared. Then I already have a cosine to the fourth in the problem, and there follows that one sign that I saved. All right, before we can take the integral then, we need to split this up because we have this product times this binomial. So I'm going to have to multiply these times the 1 and these factors times the other member of the binomial. So to split, I'll make two integrals. So when I multiply this by 1, I just get cosine to the fourth sine x dx. Now I'm going to multiply this times cosine squared. So I'm just distributing. I see a negative sign there. It appears here. I'll put it outside this second integral that I'm forming. And I get cosine to the sixth. When I multiply the fourth times raised to the second, I get the sixth. And sine x dx. You'll notice now that both integrals have a u du situation, and that's why we saved the sine x. So our u is cosine, lost an x, cosine x, and sine x dx is our du over here. we have cosine to the 6th x is our u, and this is our du. All right, integrating then. We kind of did it in our heads, but you feel free to write out u's, the expression in u's. But we know that it's u to the 4th du, so that integrates to u to the 5th over 5. So I'll go right on in and put cosine x to the 5th over 5. And then I go to the next one where we have it raised to the 6th. So that's going to be cosine to the 7th over 7. And after I take the integrals, that's what I get. Oops, I made a boo-boo. Do you see it? 2 hands up. When I said this was our u, our du is negative sign. So I did have to adjust up here. This had to be negative. That'll force this one term to be negative. And then over here, we already had a negative after we distribute it. So when I pull out a negative here, an extra negative, we get a positive. So I had a sign, S-I-G-N error there, sorry, plus C. We did one other example, and I will show you that example now and give you the assignment. All right, another paper. All right, the other example looked like this. Cosine cubed x over square root of sine x dx. We began this one by rewriting it so that the sine was up in the numerator, but it's going to take on the exponent negative 1/2. Now, with that, we can continue, and we're going to use the same strategy that we used when we had an odd number of sines. So at this time we have an odd number of cosines. So we're going to save one and change the others. So if I save one out, I have cosine squared left. I still have sine x to the minus 1/2. And here's the cosine x that I saved out. So I'm going to replace, using the key, I'm going to replace cosine squared with 1 minus sine squared. And then I have sine x to the minus 1/2 cosine x dx. My distributive step is a little more icky, but doable. We're going to multiply that times that, and that times that, creating 2 integrals. The first one, when I multiply this expression by 1, is sine x to the minus 1/2 times cosine x. So that's unchanged by the 1. There's a minus sign. And now I'm multiplying this expression times this expression. What is a 2 plus a minus 1/2? When I add 4 halves and minus 1/2, I get 3 halves. And then I have cosine x dx. All right, so we can integrate now with our u du. This is our du, this is our u. We don't have the sine problem because the derivative of sine is cosine. So our u is raised to the negative 1/2. So when I take the integral of that, I end up adding a 1 to that. So I'm going to get sine x to the 1/2 divided by 1/2. Which is the same as multiplying by 2. And then over here on this integral, I have u raised to the 3/2. There's my du. And this one will have a negative, and from this, when we distribute it, there is a negative. Our u to the 3/2 will increment by 1. So it'll be 3/2 plus 2/2. And so we'll have sine to the 5/2 divided by 5/2 or multiplied by 2/5 and plus C. So I wanted to show you how that works on both ones. All right, I think on the video, the one called From Class that was able to go up, I actually did this one. I didn't explain it, I just showed it to you on the board. And I think I wrote it in blue. So when you start part 2, which did load from our classroom, you'll be at this spot. So you can finish. All right, so hopefully, Morgan, this will load. If it doesn't go up for some weird reason, I'll have to sit with you and go over it one of these days. Let me show you something. And oh yeah, I can't remember if I shined the light on the assignment. Probably you have your book by now at home. See if you know what some of these things are. This is a fennel. This is a butternut squash, a carrot, sweet potatoes. This weird, ugly looking thing is a celery root. And this is a parsnip. So now I'm going to put all this together and stir it up and make a winter soup. So that's what teachers do when they have too much time on their hands. All right, I hope that inspires you. All right, the homework was presented on part 2, and just in case you need to see those problems, I'll shine a light on them. Hold on, I'm gonna find the book. All right. All right, the problems, I don't remember what they are right now, but it'll say so on part 2 of the video. And it's from that list somewhere. All right, good luck with your trig integrals. And I will see you tomorrow. I feel confident. Bye.